Let us now learn how to generate Fock states using the Strawberry Fields platform. Fock states are also called as the number states. So in this code, we will generate first of all vacuum state and other higher order Fock states, and then also plot the Wigner distribution. Wigner distribution, we discussed it in the previous videos. If you don't know what it is, I recommend you to look into those videos. What a Wigner quasi probability distribution is. So we first start by including some important libraries. We import the Strawberry Fields library in this manner. Import Strawberry Fields as SF. Then we import NumPy. It will be useful to us. Matplotlib and MPL toolkits. This module, it contains tools for creating 3D plots with the Matplotlib, because we will need a Wigner function distribution. It will be a 3D plot. Now let's move ahead. So then now we initialize the engine and the register. So that we do by this code. Prog, it's just the name of the program. It is equal to sf strawberry fields dot program one here. It denotes that we will be using only one mode in this particular uh, simulation. We can increase it, and accordingly we will have that many modes. Because we are talking about only one Fox state, we will only have one mode in this particular program. Then with prog.context as q, we now include a Fox state to this particular system. So this line of code below, it prepares the Fox state in the first mode of the quantum system. So Q0 here, it defines the first mode in the quantum system, and Fock 1 year, it represents that we are creating the number state n equal to 1. I can also make this equal to 0. That means I am generating a vacuum state. Now we run the code on the engine using the Fock backend. So there are different backends. One is the Fock backend, the Gaussian backend, and there is quantum hardware. I'll come to it. So if you want to run work with Fock states, we need Fock backend. If we want to uh, work with coherent states, etc., we need other backend. I'll come to it later. So we first run the engine by this particular code. We consider the cutoff dimensions to be equal to 5, and then we now go ahead with plotting. So this is the code for plotting, and here at the end we will get the Wigner distribution. Now because we had defined a Fock state n equal to 0, let us run and see how the Wigner distribution for it looks like. So yeah, this is the Wigner distribution for the vacuum state, and you can see that it exactly matches of what we learned. It is centered at 0 0, and this is how the distribution looks like. It's like a multivariate Gaussian distribution. Now let's go to the next state, Fock state n equal to 1, and this is how its Wigner distribution looks like. And we had also discussed this, that the Wigner distribution, probability distribution for n equal to 1 state, or in fact any n equal to odd state, will have negative uh, uh, values. So here we can see that it is having negative values, and also again it is centered at 0 and 0 on the quadrature axis x and p. Let us go ahead and make this n equal to 2. And you can see now this is a wigner distribution function for n equal to 2. So you can understand now that the uh, wigner distribution function can be plotted using the strawberry fields, and we will work with these states also with the coherent states and squeeze states and so on in the next videos, and learn how to implement them on the strawberry fields.